Hi, this is Renzo Huber, and in this little tutorial I just want to go through the things that I usually do when I do layer-dependent VASO imaging at the 7 Tesla here at the scannexus. The first thing that we need to do when we approach the scanner for a layer-dependent fMRI experiment and the patient is on the table is to register the patient. And you can do so by hovering over there, patient, and register it. And following this scannexus procedure, we just type in the first and last name initials of the operator, not the patient. So I'm Renzo Huber, so I'll make it Ren Hub. And I can add the year and the date because it's convenient. It's June 7th. I usually just copy paste that one to the patient ID. And now we have a phantom on the table. Let's say our phantom is 30 years old and it weighs about 72 kilograms. You can select your study. I want to select my study here, for example, using any kind of template, for example, this one. And as always, when doing head imaging at the 7 Tesla scanner, we use the head first supine orientation, and we can start our exam. It sometimes asks us for registration confirmation, the most important parameters, everything makes sense. And sometimes they also ask about if it's really the participant because the table didn't move and whatever. Just click OK. So the next thing that I do is just to run a localizer. And for example, I can just run this localizer here, drag and drop it in our queue. So now, for example, it asks us, is this really your participant? Yes, it is. We just didn't move the table after we registered it. And this error or warning usually does not appear when you register the participant before you put him on the table. The next warning is that we manipulated the transmit voltage. And obviously we did that because at 7 Tesla the automatic adjustment does not really work so well, or it takes way too long to waste time on it for the localizer. The next thing is the stimulation warning. And this is maybe important as a reminder to tell the participant that they might experience peripheral nerve stimulations following the guidelines from scannexus and the ethics consenting from FPN. Usually you explain to participant this already outside the scanner during the consenting, so we can just click OK here. So now it does the localizer. Depending on which kind of localizer you have, this might take maybe a minute or a few seconds. You can hear here, this is a very simple 3-slice localizer of the 3 orientations. You can see how the patient is lying in there. This would be the coronal section. The center one would be coronal. This would be sagittal and transversal. So now we can already align our fMRI. And usually for layer-dependent fMRI, we are using kind of SLAB protocols. As soon as you double-click it, very often it asks you if you want to use the automatic or manual mode. Never use the automatic one. It does weird things, specifically with shimming, face orientations, face encoding orientations. Always use manual. So now here we have kind of our alignment. I don't know here if we want to use a simulator visual or sensory motor setup. Let's look at a sensory motor setup. Here we have our the yellow box would be our imaging region, which is always there as soon as you select a scan and have it open here. The green box is our Shim box, which is not always there. In case you do not see it, you can always go on the right here to this button and select it or unselect it. So when you don't see it, just click this button once or twice and then you will definitely see it. Also, while we are talking about this button, sometimes after rebooting the scanner, the zoom pan is not really selected, but instead the arrow pan, which is not so helpful. So I usually like the zoom pan because then when you kind of hover to the edge of the image and now click with the left mouse button up and down, you can zoom in and out if you like. All right, then in my experiments, I usually advise people to use the 3rd order Shim. So in order to switch on this 3rd order Shim, we hit the Control Escape shortcut and then go to Test Optimizations and switch it on. And hit any key to continue. So now it's switched on. If you want to be really, really sure, you can go again and look at Shim info. And here we have 15 channels, which is the right number of channels. If it's 0, then you did not switch it on. The next thing that I want to do is switch on the third order Shim set, the little interface from Siemens, allowing us to set this third order Shim column currents. And also for fMRI, we not only want to use the third order Shim, but we also want to use advanced reconstruction pipelines. And you can also adjust those advanced reconstruction parameters by again hitting the Control Escape shortcut, and then here down for the run command we type in xbuilder there, and here we have a little editor, and you can change any kind of reconstruction parameters from the global IceConfig file, which when you click the open file button, it's usually the last one that was selected. If it's not the last one, go to medcom config ice, and then within the ice folder use the IceConfig EVP. Open it, and here we have a lot of parameters. The one I always change is iPad improved crupper and switch it to 1, from -1 to 1. Then dependent on the applications, I usually play around with the kernel size. The default is 3 by 4. Here for a sensory motor experiment, I would usually do not make the kernel that big, maybe go to 2, because after all we don't have so many independent RF channels available there. So improve crupper and the crupper kernel size. The other parameter that I also change is the crupper noise reduction 1 parameter, and I change it from 1 to something maybe of 2000. You can go to 3000, 5000. If you have artifacts, go easy on it and maybe change it back to 1000 or so. Also within the application here, go to POX and the number of iterations, where the default is 2, and I select 8. And I can save this and close this again. This file is always overwritten when you register a new participant, so you only need to change it after you registered the participant, and it will not affect the person scanning after you. Different to the third order Shim, which you always need to switch back off after you're done. So we still have this window here. Never close this window. As soon as you close it, the things might not work properly. You can minimize it though. So now we set our advanced reconstruction, and now we can do the shimming. And by shimming, while our run here is selected, we can go to options, adjustments, and then the very first thing that we do is a frequency adjust. And this takes a few seconds. And there we see, okay, we have already a nice peak and then converged. So because it converged, we can go to the next tab, the 3D Shim, which allows us to do a field map by clicking measurement, or the measure button. So this takes a while, and you can hear that it's actually doing imaging right now. It's acquiring a field map. We can look at the magnitude and phase here in a sagittal view for kind of very much zoomed out imaging. So it's not really optimized for head imaging for that matter. So here we have our phase maps. You see areas where we have a lot of phase wraps are usually areas that are not shimmed perfectly. We care about the top part over there of the brain, which is already shimmed not too bad. So now we have a field map, so we can calculate the shim currents right over there and apply them to the system. This only applied them to up to second order. So now we want to use the third order shims too, by clicking this button on this little extra window over here. And usually I go through this entire process of frequency adjust, measurement, calculate, apply, and set 2 or 3 times. So let's do it at least 2 times now. So again, I go to the frequency adjust and hit go. And very often the second time, at the second iteration, this does not converge. Voila, it does not converge, so just hit go again, and then it usually converges. So now it did converge, we have a peak and there's a yes over there, so we can go to the 3D Shim and again do measurements, which again acquires a field map, which is then used to fit the higher order spherical harmonics onto it to get the respective Shim currents from it. Okay, we are done here. So now we can again calculate, apply, and set. Usually I do it 2 or 3 times. Here you can see that already from the first to the second iteration, it did not change a lot. So this should be actually okay already. So I can close our manual adjustment window. This one I do not want to close. I only want to minimize it. In fact, if you want to close it, it asks you, do you really want to close it? And yeah, you don't, if you're not done with the experiment. If you want to get back to that window, you can always hit the Alt-Tab shortcut over there, Alt-Tab, and get back to your little GUI to set the third order Shim currents. So now I hit scan, and I'm basically done with all the adjustments that are necessary for the layer-dependent blood volume or VASO imaging, if you use that with these kind of slab approaches. The things that I usually change if something does not work out are that I kind of flip the phase encoding direction in order to not be annoyed by the background noise. Now for the recording I stop the scan. So you can flip the phase encoding direction by here rotating the field of view by 180 degrees, which is then gives you a phase correction from P to A, and usually the artifacts are quite different there. Another thing that you can do when the images are not looking great would be, for example, to go easy on the Chrsi regularization, which is the parameter that we set from 1 to 2000, and you can, for example, set it to 1000 or another parameter and see if the artifacts are still kind of okayish. So for example, let's do that right now. I again go Control Escape, go to the run window, hit X Builder, and then open up my ICE config yet again, and for example would change my iPad Chrsi regularization from 2000 to 1000. I would save it and close it. So now images are being acquired. You can see that the first images are coming in. You can look at them in real time in this little window over here, which now in fact would be the last run. This is a noise run for Nordic reconstruction if you want to use that. By the way, all of the VASO sequences should have it as part of this one here, the Nordic, if you want to select it or not. So now another thing that sometimes becomes useful is to do retrospective reconstruction. And you can do so by again doing Control Escape, and now in the run command not executing XBuilder but executing Twix. This did not work because I didn't execute Twix, but I executed T. So again I do Twix, and this here gives you all the raw data measurements that have been acquired in the last, I don't know, day or two. So here the last thing that was acquired is my fMRI run number 1, which is kind of listed here as well as in this little window. As soon as you select the window on the left, it usually is also highlighted on the right. If you want to do retrospective reconstruction, you need to select it on both, in fact. So now if you want to change any parameter, you can hit this little button over here, and down there you can edit it, and now you have an entire huge list of parameters that you want to change. For example, let's change something. Let's scale the images by a arbitrary number. So for example, if we look for additional scale factor, this one over here, we want to now scale everything from the range that we had before down by a factor of 2. So we multiply it with 0.5. For example, in case you have clippings or something like that, you would save this. You can close it if you want, and then again hit start. So now it does the reconstruction again, and this would be the crop kernel fit, and now it's actually done. You can look at it in real time if you click on it fast enough, or in this little window over here. So now we actually have this run twice. We can refresh it over here, and now we have this parameter twice. Another thing that you might want to do with this little Twix is to save the raw data. For example, if you want to reconstruct it later on, and you can do so by right-clicking the row over there and then copy images to copy total right file. And we want to do so in any folder that we have access to. For example, here selecting the BU server, going to your folder, so I would be l.huber, and then dump it right there. So this is being dumped, and you can see down there it's being written to file on the BU server. Note that while you're exporting and then sending these raw data somewhere, you cannot start a new experiment, though you can start the export while the experiment is already running. So note that in case you want to export a very big data set that might take maybe half an hour, you cannot start a new scan during this half an hour. All right, we save this, we can close everything, and now let's assume we are done with our scan, and we can close our patient again. And now we want to export the data to our folder, the DICOMs now, not the raw data. And you can do so by going to the patient browser, hitting this little button over there. Alternatively, I think you can open the patient browser by going to patient and browser. And then this would be the last set of experiments that we did. You go to transfer, export to offline. And now you can select your folder again where you want to save it, and again I'm trying to find my folder l.huber. We can, for example, give it a new subdirectory, maybe something of tutorial 1, and we want to select the format DICOM and just hit OK. Now the new subdirectory tutorial does not exist yet, so it asks me if I want to create it. Yes, I want to create it, and this is now being sent. You can check the status of your transfer request by going to local job status. So now you see here the entire patient is being sent, and nothing is failed and nothing is remaining. So this happened pretty quickly. Okay, now we can also close this one, and before we leave we should not forget to switch off the third order shim, and we do so by for example first closing the little third order shim interface with Alt Tab, this one. So now we want to close it. It warns us, so you really want to close it. Now we are done. We do want to close it. But we still did not switch it off, the number of channels from the third order shim. So now again I go to Control Escape, Test Automatizations, and now right at the bottom here we turn off the third order shim. We close the script by hitting any key, and I would advise you to check that it really worked, and you can double check always by going to Test Automatizations and using the scannexus _shim _calc _info_xm. And there it should be 0. When you leave the scanner, it should be 0. And in fact, it should also be 0 when you approach the scanner. If it's not 0 when you approach the scanner, somebody before you screwed up. Please always switch it on after you're done, off after you're done. All right, thank you very much. I hope this is useful, maybe also as a preparation for the BU test to get access to the scanner. And thanks for watching.